Hello dear students, how do you do? Had your breakfast? Yes, I too had my breakfast. Okay, in the last class we have understood the various steps to be followed so as to compute the total length of the curve which occurs, right? Under direct step method. That is the only method which is the most convenient for solving the numerical problem. Perhaps based on this reason only, it is only included in your syllabus. Other methods, just to know how many methods are there, how they behave or how they are used. That's all, very brief. Okay, just we will repeat this or refresh this. So what is the step 1? What is step 1? Yes, after knowing all the quantities, first of all compute the area, wetted perimeter, hydraulic mean radius. Very quickly I will revise it. Repeat it. Step 2, compute the average velocity V, velocity head V squared by 2G, then specific energy E at the section where the depth is known by using Church's formula or Manning's formula to find out the velocity. Step 3, assume new depth. That is another section which is as close as possible with respect to the previous one. Then compute all the above quantities as we did up to step 3. And then step 4, delta E you can calculate, E2 minus E1, the specific energy at the second section minus the specific energy at the previous section, that is Y1. After finding out that compute SF, compute dx using the equation dx is equal to E2 minus E1 divided by S0 minus SF. Repeat the above steps from each reach to reach till the required depth is reached. That's all. Useful hints. The calculations must proceed upstream in subcritical flow and downstream in supercritical flow to keep the errors minimum. Why it is to be followed? So as to keep the error minimum, we have to proceed upstream in case of subcritical flow, downstream in case of supercritical flow. That you should remember. The steps need not have the same increment in depth. Even that increment can be changed also. For example, 1.8 meter, 2 meter, 2.2 meter, 2.4 meter. This is at an increment of 0.2 meter. This can be changed also. There is no hard and fast rigid rule. The calculations are terminated at y is equal to 1 plus or minus 0.01 divided by 1 plus or minus 0.01 multiplied by y0. The accuracy would depend upon the number of steps chosen and also upon the distribution of step sizes. So how many number of steps you choose and what is the distribution of the step based on which the accuracy depends. When calculations are done through use of a hand calculator, care must be taken in evaluating delta E, which is a small difference of two large numbers. Okay, please remember these values will come in terms of, for example, 2.1 multiplied by 10 to the power of minus 6 or so. So very small value. That's why when we are using hand calculators, we should be careful. That's all. This is standard step method. If you are interested, you can go through, everything is there. I do not wish to explain along with the sketches and all. Just it is being prepared PPTs by Professor Taji sir. I am very much thankful to him, but it is of no use as time being. Time being means from the point of view of examination and so as to cover the syllabus according to Pune University, it is not included in detail. Okay, that's why we shall not get ambiguity and unnecessarily confusions. That's why I am pushing it off. Thank you. These are all the summary We have seen in detail. I do not wish to say again and again lengthy formulas, different types of slopes, mild slope, steep slope, critical slope, horizontal slope, adverse slope, everything we have seen. These are all summary once again, along with the curves have been printed here. Once again, methods have been given, steps are given again. Just copy paste, copy paste. Now numerical problems. Okay, so what we do is we take one numerical problem only today. Let us see next. Same as I said, first of all, you make firm your mind. Whatever the steps 1 to 6 we have studied and followed and understood theory, same we have to write in the form of a tabular column. How it is being written and how in a simple way we can solve the numerical problem, just we will see now. Okay. Find the slope of free water surface in a rectangular channel of width 20 meter. Let me take the blue color pen so that if I underline on red color with good background, we can identify. Find the slope of free water surface in a rectangular channel width of 20 meter and having a depth of flow of 5 meter. The discharge through the channel is 50 meter cube per second. The bed of the channel slope having 1 in 4000 with the value of H is constant 60. Right? Write down the data in terms of symbol always. Width B is equal to 20 meter. Depth Y is equal to 5 meter. Discharge Q is equal to 50 meter cube per second. S naught is equal to 1 in 4000. C is equal to 60. Immediately write down the formula dy by dx is equal to S naught minus SF divided by 1 minus Q squared T divided by GA cube is equal to what? Compute SF using Chej's equation. Q is equal to AC whole multiplied by RSF, where SF is equal to capital Q divided by A, that is nothing but V squared divided by C squared into R, where R is the hydraulic mean radius, or also known as hydraulic mean depth, that is nothing but area divided by wetted perimeter. If you substitute the values, you will get SF is equal to 2.085 multiplied by 10 to the power of minus 5. Compute dy by dx using GVF equation, you will get 2.303 multiplied by 10 to the power of minus 4. So these things you have to substitute the values and you have to calculate. Over. One numerical problem. It does not require more because it is start with simple. What is asked? Find the slope of the free water surface. That is dy by dx is nothing but 2.303 into 10 to the power of minus 4. This is the simplest problem that can be asked for 3 marks. Not more than that, only 3 marks. Now, a rectangular channel is 8 meter wide. It has bed slope of 0.00025 and a uniform depth of 1.8 meter. Uniform depth, that is Y. A weir is constructed at the downstream end of the channel, thereby water surface at a specific section is raised by 0.9 meter. What will be the water surface slope with respect to horizontal at this section? Take rugosity coefficient is equal to 0.025. So write down all the parameters in symbol. Width B is equal to 8 meter, depth Yn is equal to 1.8 meter, uniform depth. S naught is equal to 0.0025 and N is equal to 0.025. Therefore, actual water depth Y is equal to uniform depth 1.8 plus 0.9, that is raised because of the provision of VR. Constructed a VR. Therefore, water surface slope SW is equal to S0 minus dy by dx. So dy by dx is equal to, first of all you shall find out dy by dx as in the previous case. Then substitute here, S0 is given. So S0 minus dy by dx will give you actual slope of water surface. Here velocity or discharge is not given, and hence first compute velocity using Manning's equation, take slope S0 and hence y is equal to yn. Then calculate SF using Manning's equation, take slope SF and hence y becomes y. Substitute Manning's equation, v is equal to 1 upon n S0 half whole to the power of half r to the power of 2 by 3. You will get v is equal to a is equal to b into yn. P is equal to b plus 2yn. That becomes area 14.4 meter squared. P becomes 11.6 meter. V is equal to 0.7303 meters per second. But on downstream side, depth has been increased. Hence, again using Manning's equation, take slope SF and hence y is equal to y. That is equal to 2.7. V is equal to, again substitute the value, you will get SF 1.765 multiplied by 10 to the power of minus 4. Now using GVF equation, dy by dx is equal to this formula. Substitute, you will get 7.85 into 10 to the power of minus 5. Now slope of water surface with respect to horizontal, SW is equal to S0 minus dy by dx 0.00025 minus 7.85 multiplied by 10 to the power of minus 5. That gives you 0.000175. Okay. Okay. So next problem, that is third problem, is actually following by that table. So this problem can be solved by using table which we have studied while doing the direct step method DSM. By using that big observation table we have to do. There are around 13 columns. Depending upon number of steps to get the accuracy, maybe single step, maybe 2 steps, maybe 3 steps, depending upon. Okay, that we'll take in the next class. Thank you. Please practice at home quite a number of times. As much as you practice, so much will be easier. Okay, boys and girls. Thank you. Have a nice day. Have a nice day.